Today, or in this talk, I want to talk about how to integrate with existing tools you might already use in your environment, or tools you might consider you want to use and which don't, well, or maybe they don't ship already a Gradle integration. My name is Rene Groeschke. I'm working for Gradleware doing Gradle core development and some sort of consulting in the area of continuous integration and all the stuff we do. Yeah, I have some demos prepared. Hopefully, well, I guess they will work. So one thing is, why do we need to deal with existing tools out there? The problem, or not the problem, the main reason is, or some reasons are, there are so many cool technologies out there. There are so many cool or awesome tools out there. They're really, while preparing this talk, I just stumbled upon a new tool I haven't met yet, or I haven't seen yet. I prepared a demo for it. It's from the J-Rebel guy, or the Zero Turnaround guys. And there are so many tools dedicated for a specific focus. And Gradle itself offers a lot, built-in plugins, built-in functionality to deal with all kinds of build-related stuff, but we can't, or Gradle can't, deal with everything. We can't model every domain and ship it, so we have to integrate with it. The other story is that how many of you have to deal with polyglot environments where you have, or do you have pure Java? I guess you don't, right? You have pure Java. Yeah, most of you. In the past it was, or I remember when I started to work after I studied, it was, having a polyglot environment was a bit like legacy. So it was there was this old C++ stuff, nobody wants to deal with it again. But now it comes back, right? You have all this cool kids doing JavaScript. You have Cocoa, things like this, native iOS development and Android development. Yeah. But there's still all those legacy stuff you have to deal with. Last week I was at a customer, and they have a huge stack of C++ code, and it just works out of the box, right? So they have the system, how it is built and how it is compiled, and you don't want, when you want to integrate it with your new build infrastructure, with your release management and stuff like this, there's no need to reinvent the wheel. So you don't need to tackle this again. So you can, what you want to do is you want to reuse the stuff you have and you relied on in the past, and things, if it works and you don't want, or you don't need to change anything, you just don't need to touch it. Because if you would, often when you start with those things and you want to, or you start reinventing the wheel, it ends up something like this. Or at least when I did in my former company, when we thought about starting a new project, it was all about technology, right? It was, the new developers talked about, we can do new mechanisms, like we can do TDD and stuff like this, and we can use this and that technology, BDD, all those frameworks that are out there. And the problem with that is that developers like technologies, right? They like new technologies. And often what I saw in the past was that people often try to write their own tools, which are leveraging, I don't know, maybe some ARN stuff, maybe some other stuff. The problem when starting a new project or having an existing project is that your boss has a bit of different idea about what the focus of the project is, right? So, and the reason, and to have a project, and to what you need to do, or what your boss wants you to do, is you should focus on the domain you are working on, right? You don't need to write, or often people tend to write own tools, even though there are exactly tools out there for this stuff. So you should focus on your domain. You should focus on your product, on your whatever you're developing on, and and what you need for that is to have you need a good development workflow. So you need a workflow that where you can model how your sources developed or created on your machine on the developer box end up in the release, right? You want to have one development workflow coming from setting up your IDE, checking out IDE, whatever you like, checking out the sources where they are stored using whatever, Git or any source control, and you want one nice maintained clockwork to do this, to have one way that describes how your sources end up in your release, right? And the others, there are different things about this. One story is, of course, the traceability. If you have a bug or something like this, you need to know where it comes from. Who, maybe you want to blame somebody with, I don't know, but at least you want to know how this bug was introduced or since when it is there. And the other stuff is when you're working in big companies with huge or big amount of developers, you want to have an easy onboarding process when you took new developers from university or so, and you explain them, well, we have a build tool called Gradle or so, or maybe Maven. They know how to work with this. But if you go there and say, well, we implemented something on our own, you need a wiki page to point to, you need to explain how it works. I was at a customer some months ago, and they wrote their own source control system, and it was ridiculous, right? Because because they write their own source control system, and it was not a technology company. It was actually a bank, not a bank, not a service provider for dealing with bank software and stuff like this. So, yeah, unfortunately, what you often find is, or you find something like this instead of this one, you find this. The reason for that is often time, especially Java projects that are projects usually that have a longer life cycle than the small startup stuff I usually see when I discuss things with Ruby developers and so. So if you have invented something on your own, tools for dealing with whatever scripting, whatever you need to do, they might be shining at the beginning, but the problem is normally those internal tools are not often good documented. They have their issues, and they might tackle what they are developed in for, but as later in the process or in the development life cycle, you get there, the maintainable or the effort to maintain those stuff just raise up, right? So what you need to do is you can maintain them. So you need dedicated teams or dedicated developers to maintain those stuff. And what you also need is to have those traceability, that this gear wheels work together. You need something like, oh no, yeah, another slide, what I want to say is, and when it comes later to releases with a pipeline like this one, you get into this situation where you want to say, well, we have to do a release and everything is, or there's panic going on. I had this in the past when we did releases in other teams I worked with. It was all about doing overhours and yeah, postponing releases, stuff like this. And at the end, there was this tiny little issue we haven't tackled, and the release was, well, we had to do another one, a patch and stuff like this, working at the weekend. So you don't want that. What you need to have this traceability or traceable tool chain in your environment, you need, yeah, some oil can. Something that brings all the stuff together. And this is where I think Gradle comes in. When Gradle was founded at the beginning, since, I don't know, 4 years or so ago, or 5 years maybe, at the very beginning it was designed to integrate with others, right? At the beginning, lots of stuff was based on ART. It changed during the time. But Gradle offers out-of-the-box first-class ART support, so it integrates nice with existing ART system. And the other story is that dealing with the whole dependency management with the server-side part of this story, or what Maven and Ivy invented, we don't wanted to reinvent the wheel again. So there was this whole infrastructure out there dealing, customers dealing with Maven Central or Sonar or whatever, or Nexus, whatever they have. So we are integrating, Gradle is integrating nicely with this one. And there are other things we ship as part of Gradle, like the IDE integration, or Jacoco as an example for a third-party library dealing with code coverage. Yeah, so Gradle is designed for integrating with other tools, but usually in a bigger environment, what Gradle ships is not enough to tackle your issues, right? You want to use, maybe you want to use things like JavaScript. You have to do this polyglot stuff I talked about, dealing with some native code. So Gradle offers some tools, or gives you some tooling for that to deal with what I call the unknown, right? Gradle is not supposed to know everything you want to implement or what you need to implement, but it offers you some tooling to deal with this. And I have about, I don't know, 6 patterns or so prepared to show how you can integrate third-party tools, or let's say external tools, with your Gradle build. The first one is quite obvious. There are plenty of Gradle plugins out there. Who of you wrote a Gradle plugin before? Okay. Who of you comes from Maven? Let's ask this way. Have you ever write your own Maven plugin? And was it nice? In Gradle, writing plugins is a much lower effort. It's just, basically it's just implementing one method. And if you're lucky, there are already plugins out there. For example, this third-party one, Gradle ships with a Jetty plugin with its limitations. But there's a third-party contribution for integrating, for example, Tomcat. And this is all it needs to integrate or let your war project be executed to run it with Tomcat. And for those of you who haven't seen that before, you have to define the repository where you want where the plugin is located, and then you define the Maven coordinates where to identify the plugin, group org.gradle RP plugins and Gradle Tomcat plugin and version 098. And actually you apply the plugin. Let's have a small demo for this one. what I have here is a quite simple Java project, which is a multi-project build with some dependencies. I think nothing special. Yeah.
So when you had to add the dependency for that plugin, you're not specifying any repository for that. So where's it looking?
I did. I did
did
here.
Sorry. Okay.
So this one is luckily hosted at Maven Central.
Okay.
Yeah, you can use different ways. There were people or developers put their code. In the past, they put it often on GitHub, but they don't support binary dependency anymore. So I think you can't use GitHub for hosting your binary stuff. They just changed it somewhere. Yeah, Bintray. Okay, this is a new cool kit in town. Yeah. So back to this. This is a basic Java application. So I have some repositories declared, some dependencies, and what I did here is I applied the application plugin. What the application plugin does, it offers some tasks to create a full distribution, creating bash scripts, stuff like this. All you need to do is apply the plugin and define the main class name, so org-acme name. What I can do then is say run, just as I'm not a swing guy, so excuse for this. And now I have the requirement for this one. Yeah, main. All those Maven fanboys, what they want to have is they want to have a native app for this, so that you don't have to run java-jar or stuff like this, or this crappy bash script stuff. So they want to have a native bundled or make bundled version of this. So what you can do for this is you can Google what Gradle plugins we have to offer for this. Actually, we don't ship anything for this, so you need some sort of third-party plugin. Yeah, and what I do is I do something similar. Instead of using Maven Central, I take this stuff from Google Code. You can, with Ivy is a bit more flexible when it comes to resolving artifacts. So you can just do something like HTTP Gradle make app bundle, and then resolve it from Google Code. Right, what you do here is you actually declare a pattern how the file can be found. So you say module, module. And the revision, which is the Ivy term for version. Actually, so done with this. So what we're missing is, so we need to declare the file, dependencies. So what you actually do here is you extend the class path of the Gradle build itself. So we add a class to the class path which is used by the Gradle runtime. So 1.8, something like this. And now you can apply the plugin. It needs some configuration, so you have to declare. It offers you configuration section named make app bundle. So you declare the main class name, which is like I did before, and you can do something like configuring an icon. You can do some more stuff like, for those of you using Mac, you can declare background images for the DMG file and stuff like this. So when I now run Gradle tasks, what I see is, go a bit on top. there's a new section about the Mac, about the tasks which are offered by the Mac app bundle. A lot of them are more or less helper methods. The important one, I think, for example, this one is a create app and the create DMG file. So when you run Gradle assemble, you can see the app is created and the DMG file, which is some kind of installer for those of you using Windows or Linux. And there you go. You have the there's this app file created, and you have in distribution there's this DMG file for as an installer. So, and when running this stuff, Mac app. Yeah, just the same application, but you have now a native application here, right? Nice stuff. Yeah. So, and what you can do, maybe what you might want to do is to put or extract the logic for dealing with the makeup bundle externally. One issue you have now is that you declared the main class name twice, right? You did it once for the application plugin provided by Gradle, and you do it for the make app bundle provided as a third-party plugin. That's one issue you have to deal with. You can either write the plugin on your own or you deal with its limitations, right? So what you now can do to clean things a bit up before we finish, we can create a macOS Gradle stuff and put all the logic dealing with this make app bundle stuff into a separate file. And now we just need to apply the script. So, yeah, so quite easy to use, full supported by Gradle. It's its own plugin system. There are some pros and cons. Obvious, there are some pros about it, but there are also some cons about using existing plugins. One pro, of course, is that in best case, somebody tackled exactly what you need. So you just need to grab the stuff and configure it, and don't have to do something else. They're easy to reuse. Since they are packaged as Java files, they are normally published to some sort of binary repository. They're easy to reuse. Normally tested by the community. Of course, how much they are tested, it depends on the plugin, of course. For example, if you have some exotic stuff like, I don't know, moving your something really dedicated or so, it might not be tested that well. But for example, let's say another example, the Android plugin, I think it's much better tested by the community because the community is just huge, right? But the cons, or the one thing you have to keep in mind, is that that it might not fit your specific needs. If it's, for example, the Tomcat plugin, or let's take the Mac app bundle we just used, if it does not offer you things like configurations like you want to do, custom installer, maybe more customization to the packaging stuff, you can extend it, or you might need to write your own one. And the other issue is that you have to deal with its limitation, which means, for example, what we saw, we have to declare the just as a tiny example, you have to declare the main class twice, even though it's some kind of duplicate code, so you have to deal with its limitations. Often it depends on who wrote the plugins. There are some guys like, I don't know if you ever saw plugins from Benjamin Mushko or so, he's writing tons of plugins, or Andrew Oberstar. They are doing a lot of plugin development and they are usually well tested. Other guys just, well, they publish their stuff because they can, or GitHub is so nice. But it's often you see plugins out there which are not really written and with keeping in mind to be reused. It's more like it does exactly what I need, but it does not. They haven't thought about more on a more high level or general stuff. And often they have a lack of documentation, right? Often you find just a binary, not lot of lots of documentation there. Yeah, you have to deal with this one too. One problem with Gradle plugins is how to find them. Actually, this is our current plugin portal, which is a wiki page. It's a bit, yeah, we're working on a plugin portal which is baked or more, which offers more support, like automatic testing, things like automated version checkup, stuff like this, comments, rates, all this stuff. What you have here is just a wiki page, and it can be edited by anyone. So there's usually or often there are no information about when was this plugin written or when was it, which versions, Gradle versions are supported. And I know at least one of them which is not working anymore, and this is number 5, the SBJ plugin. I wrote my own. I just haven't removed it from there, right? That's something we have to tackle. We have to provide some sort of plugin portal. I think, Hans will talk about this story this evening too. I mentioned earlier that Gradle ships with ART tasks or with fully ART support in it. So in the beginning, when Gradle, I don't know, 0.4 or 0.5, we discussed this yesterday. A lot of the stuff in Gradle was just a wrapper about ART. For example, all the copy operations and stuff in the past were more delegators to the ART task. Lots of stuff changed to our own API, but you can still use existing ART tasks. So, for example, you have built-in support to some degree to publishing things by using FTP because ART supports FTP. Yeah, that's just an example I grabbed from, I think, the user guide or so. You can also do more sophisticated things like if you have to deal or you have to declare your own or want to use third-party ART tasks like the SBJ compiler, you can you can do this too. You have to declare the task def snippet and then use it. It's actually the ART support in Gradle is based on the Groovy ART builder. I don't know if you're aware of the Groovy ART builder. Groovy ships with this ART library, which is a wrapper which offers this builder, this builder style thing to configure ART stuff. There's some pros, of course. ART tasks, as mentioned, they are first-class citizen in Gradle. There are thousands of ART tasks available. I think, I don't know, everything is shipped as an ART task. Usually, all those major software companies, like I don't know, the JBoss guys or the JBoss WebSphere. Every major software stack is providing ART tasks for dealing with their environments and stuff like this. Again, they are normally good tested by the community. For example, take this aspect-J compiler, or the FTP stuff. They just work, right? So you have to deal with this anymore, or there are usually less limitations or less bugs in this stuff. And they are usually well documented. If you use, especially when you use built-in ARN tasks like the FTP stuff, they are well documented all over the internet if you Google for it. And migrating things from ARN, if you have an existing ARN task and you just want to have a tighter coupling, or you want to integrate it more nicely in your Gradle build, it's some kind of a no-brainer. Just converting the XML syntax in this new builder syntax provided by the Groovy ARN builder, right? So straightforward, no surprises at all. What they don't offer out of the box is the incremental task support, or who of you does not know what incremental tasks are? Good. So you have to model this stuff on your own. You have to model the inputs and the outputs if you want to have this incremental Gradle feature. Some recommendations for that. What I usually do is wrap, or when starting with porting some ARN stuff, or include some ARN stuff in Gradle, I use a dedicated Gradle task and map and do a one-to-one mapping by mapping one ARN task to one Gradle task. Usually in Gradle, or normally ARN tasks are more fine-grained. You can have targets or stuff like this, but normally I use a task and map them directly to Gradle task. What you can do, what's pretty easy in Gradle is to model the inputs and the outputs. You can do the, for example, if you have this snippet here, you can do it ad hoc by declaring it as part of the task declaration here, or if you want to reuse it more often, you often write your own task implementation, which just delegates to the ARN stuff. Sometimes the one-to-one mapping, what I mentioned earlier, does not make sense. What I mean by one-to-one is that not every ARN task must be one Gradle task. For example, often there are more stuff about it. For example, there aren't when you do what I did. What comes in my mind was I did some wrapping for ARN tasks dealing with Nexus, and they do some kind of, they offer low-level support, creating staged repositories, stuff like this. And often you want to model, if you want to model a workflow, stuff like this, you might want to use multiple ARN tasks in just one Gradle task. It depends on what makes sense for your use case, let's say. So, yeah. The third pattern, I named it Java driver available. It's also about it could also be named Java library available. Let's do a demo about this one. So what I have here is let me check. This one. This is the one. So what I have here is basic, simple, very simple Gradle build, doing some tests. And what I want to have is, what I would like to have is, I want to log this test. Normally they are created in sort of XML file, and I want to keep them somewhere persistent. So what I can do for that is I can store them in a library, or I can store them in a database somewhere. And what I can do is I can put them, or let's put them in some sort of, in a MongoDB or something like this, to store them and later to look them up and analyze them. So what I did here is I created a dedicated build source directory. Who never saw this build source directory? It's about, you can have a dedicated directory within your build script. And what it does is it models a whole project for you, and all the stuff you implement in this project is automatically picked up by the Gradle build. So all the classes you define here can be reused in your Gradle build. So I have a build script here where I say I need the Gradle API, and I need local Groovy support, and I want to deal with MongoDB stuff. And what I can do is when I usually do MongoDB stuff in Java, I would use a Mongo Java driver. Since Gradle is based on Groovy, and what you should do when doing this sort of stuff, you should look if there's a better, or let's say and more nicely Groovy layer on top of the Mongo, for example, for the Mongo Java driver stuff. There are tons of extensions Groovy-wise, dealing with MongoDB, dealing with all sort of SQL statements. They offer just a more nicer DSL. You don't have to deal with all those Java boilerplate you have to do usually. So instead of using the Mongo Java driver, let's instead use, it's called gmongo, some kind of abstraction. So, and since I want to write some classes, I don't want to use TextMate anymore. I would like to have some IDE support, right? So I can just apply the IDE plugin, which generates the IDE metadata files, and let's open this one. And the nice thing about that, or when you write your own classes and just use Groovy or Java libraries, you can rely on the IDE support. That's pretty nice. So let's create a new Groovy class, and we call it Mongo TestDB listener. We want to implement our own test listener. Test listener is an interface Gradle provides, which you can use to just hook into all the test results and stuff like this. So we just need to, this is a gmongo API. So let's want to do it this way. If we start the first suite, we want say, or the main suite, we want to create a new gmongo instance and create a new DB. Actually, I just hardcode the string. You can use whatever you want, of course. So have a field there. And now what we need to do is just after, that's not the right place. So after test is executed, we take the test results, figure out the duration, stuff like this. And yeah, that's a nice thing about using this Groovy layer on top. You just can use a very one-liner to create new record for your MongoDB entry. So we take the test descriptor and say, give me generate a string for you. Let's do it this way. What else do I need? I want the result. So I can say test result. And what I also want is a duration. So duration. So have to do sorry. Yeah, and now what we just can do, for we are back in our project and we say test.addListener and we use this new class. Quite simple. And now we can run this stuff. Let's clean to be sure the tests are executed. We'll see all tests are executed, and now when we looking back in our, when we go to our MongoDB, we have all the test results in there. So we can use this for, I don't know, if you want to do high level analysis about your failing tests over time or stuff like this, or you want to figure out which test fails how often in the past, yeah, you can do something like this. So the good thing about using Java or plain Java libraries or plain Java libraries, they offer the most flexibility for you. So you can, you can use all your developer know-how, your Java know-how to implement exactly what you need. And if you rely on Java drivers provided by the developers of the tools you want to use, they have usually high quality. Like the MongoDB driver, you can this is stable one provided by the MongoDB guys, right? What you should do, as mentioned, is you should look for a convenient Groovy layer on top. Of course, it depends on how good your Groovy knowledge is, but normally it's just easier to use some sort of those Groovy convenient layer on top instead of dealing with all those plain Java stuff. And the good thing, since we just rely on plain Java, we can use all the infrastructure for dealing with our dependencies and stuff like this. We don't have to deal with environment setups or anything like this. Modeling, what you don't have when you use those Java drivers, if you want to implement a task or something like this, there's no model which offers you a one-to-one mapping between what the Java library offers and what your task is supposed to do, or the same is true for the plugins. So, what else do we want to see? Now, what we tackled so far are just plain, let's say, JVM things. We dealt with ARN tasks, we dealt with Java drivers or those Gradle plugins, which can be just resolved from Maven Central, stuff like this, using the Gradle infrastructure for dealing with the plugins. But if you have polyglot things, who of you is doing some sort of native development? Pardon? Yeah, script, Python or whatever, or Cocoa, or I don't know, some sort of command line based stuff or things like this. What I have prepared for this one. So what I have here is a sample, or a very simple Cocoa app. I'm not a Cocoa developer at all. What it has to offer is a nice Gradle logo. Nice is relative. Just to show you how the integration works. And when you deal with this sort of things, where you, for example, have an Xcode application where you want to integrate this native stuff in your Gradle infrastructure. How should you, or how can you do this? Xcode offers a built-in command line tool for building those stuff from your command line. Usually all editors do, or IDEs do, like I think Visual C does something similar. What I use in this example is something developed by the Facebook guys. They write some kind of convenient, a more convenient command line tool to deal with Xcode applications or sort of iOS or macOS stuff. So what I have here is I have some test cases. So one is failing, one succeeds. And usually this, what's shipped by the Xcode guys is this this Xcode build. This is the one shipped by the Xcode guys. The problem with this is it provides, I don't see no value in the output. It has some limitations in sort of you can't. There's no good way to understand which tests are failing. There's no test report or stuff like this. The build succeeds or it fails. So what I use instead is this TestXz tool. So here's the output. Everything done just for creating a simple Cocoa app. So instead of this, I use this XZ tool. It's just more convenient to use. So I have some options to deal with. And what you need is you want to now integrate this command line tool with your Gradle script. When you start calling command line things, you can use Gradle offers you, for example, there's an exec task or there's an exec function provided by or as part of the project API. It offers you the exec mechanism where you can just specify the command line, specify some args. You can pass properties like usually Groovy code. So and what we have here is there's this clean XZ task which calls the XZ tool with just a clean task, and we have this build XZ task having mostly the same arguments. They just differ in one line, right? So what you so you can run this build XZ straightforward. It builds your stuff, everything fine. So let's take a look. I put this simple Cocoa app in there. Here we go. Just build it just fine. So the problem with this is again, when we look at the build script now, we see there's a lot of boilerplate out there, right? So we have lots of duplicate code. So, and if I want to run another task, or I want to change something in the arguments there, I want to change the target directory, I have to do it twice, right? That's not what we want. So running the clean exe again. So it works. What we should do is we should refactor it, and so that it uses the same, or let's say the same base for its the same base for clean exe and build exe. So we write our own task. Gradle ships with the exec task we can use or we can reuse. So we can use the same API for configuring this exec task and as we do for the exec command here in this section. So now what we do is we just say, okay, you are of type xt, and you now just have one file left, right? So we want some get rid of those. There's some typo. Should be this way. So now you have a simple mechanism or you now have a way of a central place where put your logic how to deal with this XC stuff, and you drag the arguments for creating or building it and cleaning it in a separate task. The problem with this is normally you have just a bunch of tasks you have to deal with, and you normally don't want to write, or maybe you don't want to write all those tasks manually. It's more done. If you see this pattern like we see here, we have this clean exe task with the argument clean, and we have this build exe task with this argument build. What you can do here is we can use task rules to do this in a more, let's say, dynamic way. So clean here, clean there, again. So what I can say in Gradle is can create a task rule by saying task add rule, and we say give it a name, or we provide a pattern just as a description how it should be used. We say you have to define the action and the XC. Stuff, and then we say if this string comes in, so every task which ends with XC should be mapped by creating a task named as described here with the type XC, and the argument is task name. We just want the action from the pattern here, right? So having this in place, we can now delete all this stuff. So we have just declared the task and we have declared the rule, and now you can say clean exe. This just is picked up by the rule. You can say build exe picked up too. So, and what we didn't have before was the TestXz stuff. So I can run the test the test task for running all the unit tests from Xcode, and now the one is failing. I might want to deal with this in a different way as I did for build.exe or clean.exe or stuff like this. And I can do this pretty simple. By having the rule here, I just can reference a task I want to deal with in my build script. So I reference TestXz, and what I want to have is I want to have a report directory, for example, like I have for JUnit. Let's put it in test reports. Test report. And I can say, let's put it on top a bit. What the exec task offers me, I can redirect the output stream of the just executed bash or command line thing. I can say, well, the test output stream should be redirected, or so the standard out of my task execution should be redirected to my test output stream I just created. And I can do what the nice thing about the I can modify the exit value and say ignore it for now, so don't fail first, just validate or provide a better error message, let's say. So I can say if first I want to create the report directory, and I want to write the output of the just executed task into this report directory. Call it TestXml. And the nice thing about Groovy, one-liner to write to a file, and we say new string, provide this byte output stream to an array. Yeah, that's it. So or maybe encode it correctly. So I just double check the return value. If the exec result was not 0, something must happen. So I throw a new Gradle exception with a more meaningful error message. I say, well, some Cocoa tests have failed. So when I run the test now, Gradle TestXz. Takes some time, and I get a better error message as I had before. So let's have a look in the test report. Well, TestXml, it looks not really like XML. One issue. The nice thing about the XC tool when you come from JUnit is that this tool offers, they have some kind of what they call reporter. You can reformat the output they created. And they have one option to create JUnit output. So if you run Gradle TestXz again, they have failed. Just look up the. So you have now valid JUnit XML outputs. You can grab this from your build as you do it, or let Jenkins grab this file and just show it in your normal, I don't know, CI infrastructure or whatever you use. Yeah, that's a nice thing about integrating. Using rules and stuff like this, and the exec task is quite. With those two things, you can easily leverage the stuff, right? Uh,
Test, build, and clean. Where are these coming from in the root factor?
what do you mean?
Right here.
What do you mean there?
So now, given this rule, now we have the test, build, and clean. Where is that coming from?
What you do is, what you usually do here, or what the rule means is, if you declare on the command line a specific pattern, like described here, you write action and then xc. This is just a description. The rule kicks in and creates out of the box a task for you. Another example where we use this is when we deal with, when you run Gradle, you can, for all tasks created by Gradle out of the box, you have this according clean task. So when you run test classes or you run Gradle test, you can always run clean test. And how this is implemented by using the rule, right? You have some sort of rule definition where you define this pattern that everything which starts with test and ends with something that is matching to a specific task, it deletes the outputs of the task, stuff like this. This is, rules.
So how the TestXz resolved here? It's resolved by the rule, or it's resolved?
Yeah. What the nice thing about rules is that by just declaring the rule within your build script, you can already reference it within your build script. So when you are here, you already referenced the just created task of type xc in this example, right? And you add the configuration you want to have, or modify the basic configuration you did here later on. So, there are obviously, again, some pros and cons. It's, I think, using the exact task and things like task rules is the best choice for integrating with other script language. If you have some Python stuff or so, usually they're just easy to run from the command line. The problem is, or you have often, it depends on the command line tool, of course, which you want to leverage, but normally the implementation effort is quite simple because when you just invoke, like Python, you invoke normally a script or something like this, it's easy to implement. Of course, there are downsides. The problem with this is, one nice thing is that there are, of course, every serious system in the developer ecosystem or the software ecosystem, they offer some kind of command line tool, right? So, for example, I found command line, when preparing this talk, I found command line talks for doing screenshots, for doing, I don't know, what I did in the past was, I had a command line tool and used this for when I do acceptance tests on the web, on a website, I can just create a screenshot out of it. The problem with this stuff is that they are often or normally really platform specific, and that, for example, what runs really nicely or a setup that runs really nicely on your Unix-based machine you might run into issues when trying the same on Windows. Yeah. And you have to deal with the installation stuff. You can't use all this nice dependency resolution stuff. You have to rely on the fact that the command line tool is installed on the system, right? Or you have to use other tools like, I don't know, provisioning tools out there for packaging, Debian packages or whatever you need. And again, the incremental support must be modeled by yourself. Another, yeah.
Can you explain that again, what you mean by incremental?
By incremental?
What do you mean by that?
By that?
Yes, incremental.
In short, in Gradle, Gradle knows when a task is up to date. If the output hasn't changed and the input hasn't changed, we name that task is up to date, and that's what an incremental task is, right? Another pattern or another way to interact with all those tools is using REST, JSON, remote, whatever API. Lots of tools provide those stuff, especially the CI server are quite huge in this area, or the binary repository managers like Nexus and Artifactory. They provide a huge set of or big set of JSON-based API for dealing with all sorts of things. Let's take an example what you can do here. I haven't implemented it yet. So this is a guy which attended Gradle training some weeks or months before, and Gradle provides an announcer, what means that you can say, or you can implement some kind of announcing mechanism where you want to, you can Twitter if something finished, or normally it interacts with this Mac notifications like roll and stuff like this. And what this guy did was, there's this API out there you dealing with, or the service is named pushover.net, and by just implementing the announcer interface, he did this with 55 lines of code, doing some HTTP URL stuff here. And what he did is create an announcer plugin and add this as a listener. And what you get by just adding this file to your init.d folder, for example, is you get this for free, right? It's some kind of iOS notification tool. Other examples, the nice thing about this is, again, Groovy offers a lot of nice, convenient API on top to deal with JSON and HTML stuff and stuff like this. And it's excellent to interact with tools like the CI server or the stuff your binary repository offers. They have no binary dependencies declared. That's nice too. The problem when doing remote stuff is, of course, that the robustness depends, of course, on your infrastructure. So if you have something like what I showed before with the pushover notification, it's not a good example for an enterprise environment where you usually want to rely on some sort of internal infrastructure, and you have to deal, and the whole stuff about error handling, and so you have to implement on your own. You have to do all this checking the HTTP code, mapping this to a meaningful error message is up to you. And the testability, of course, is it's not as easy to unit test as you can with a plain Java library or so. Other examples, TeamCity has a huge API for this. GitHub offers some nice features using the REST API. All those kinds of issue tracker, Jira, uTrack, or if you use some services like Trello, they offer JSON APIs where you can, for example, when you create your release, you can automatically manage the release stuff in your Jira, packaging things up, creating all those issue listing about what's implemented, what's fixed. Nexus and Artifactory, they have some sort of basically, if you just use them as a binary manager for dealing with your Maven dependencies, you can use a plain Gradle support for this. But most of Nexus and Artifactory, they offer some kind of enterprise stuff on top. So if you buy it, instead of using the open source stuff, you can do something like all the staging, or you can do things like tracing, your binaries which build which build produces artifacts. You can add custom properties and stuff like this. And yeah, Bintray as the new binary manager offers some other stuff on top. Maybe the last thing I want to show as a pattern how to interact with tools is relying on conventions. So in the Java world, mostly everything is, or lots of stuff is about conventions. So for example, if you create a war file, there is a convention where you have to put your classes and your web XML file if you want that your Tomcat or your Jetty picks this up correctly. And there are other examples out there that rely on conventions or other tools. It's often about declaring a descriptor or using a specific directory for stuff like this. And what I want to show now is when where do we have it? That's just a tool I found when I just prepared this talk, or just when I want to prepare another talk. What I have here is I have a plain, simple war application. Let's have a look. These pet clinic. The pet clinic war project is a default, or is an example project provided by the Springfolds. I ported it to Gradle. And well, it's really basic stuff, nothing fancy. And what I want to do is I want to handle some kind of deployment for the stuff. So for example, my developers or my build machine creates all those this war file, and now I need the test engineers to grab a version, install it on the machine, test it in a specific environment, stuff like this. And I just stumbled upon this LiveRebel software. It's for dealing with all sorts of deployments. It's written by the Zero Turnaround guys, those guys who wrote already JRebel. And let's have a look. So just look in. So what it knows, or how LiveRebel works, is you can declare applications, you can declare servers. I have I've just an open source license, so I just can run 2 servers in parallel. And what I can do is I can somehow I need to upload an application. And there's a mechanism called auto import directory. By just putting the war file in a specific directory, I can just auto deploy it to the tool. So what I need to do, plenty of dependencies here. Let's move on top. So I have this LiveRebel pickup directory. And I want to push to LiveRebel. And what you now just need to do in your build.gradle file is a very simple copy operation. You say copy the war file into my pickup directory. And that's it. So something must be wrong. Read the, I should have read the details. You have to provide some kind of what LiveRebel expects in it expects some sort of descriptor file named liveRebel. So this is very basic XML stuff where you just put the name of the application in and the version of the application. So here's an example. So to do this, it should be quite easy in our build file or in our project. Let's create a liveRebel XML. And what I do here now is I use some placeholder. So I say app name, I say app version. So the only thing I need to take care of is that the correct values are picked up. So I use this replace token for this. This is basic. So and as part of the process resources task, I want to modify the inputs. Actually, there's a tiny little bug in Gradle that if you use replace tokens and they change over multiple Gradle invocations, they are not automatically picked up by the up-to-date check. So I declare the inputs here explicitly. We hope to fix this at some point. And now what I do is I say replace token, and now replace everything that is project name by project name. So that should be it. So I'm going here. Now I have this pet clinic application there, and it knows that it is version 1.0, and now I can just deploy it. So it's a nice tool for all the integration testers, stuff like this, where they can easily switch between different versions of the applications. liveRebel, they offer some more support for dealing with database migration, stuff like this. So I have now here the running pet clinic stuff. So now when I go back to the Gradle file, and I change the version, so to release a new one. I have the new version there, and I can just say, if I compare them, things like this. So yeah, well, obviously the liveRebel XML is different, but everything else is the same. So I should be safe to, where is it? I can say, go to deployment and say update. Yeah, I just wanted to. Yeah, now it takes care about updating the war on your test infrastructure or maybe your production infrastructure or whatever. Yeah. That's what I meant by dealing or working with conventions. We rely on some sort of descriptor. We rely on some sort of pickup folder. The flexibility is limited, I think. Often it depends on the tool, and in this case, it's really basic but easy to pick up. It helps you to enforce standards if you have some tools in place which you rely on and you use these tools in your whole or company, you can enforce standards. For example, a war, as mentioned, is a standard, or often you want to use tools like Chef or Puppet, where these tools, for example, they expect packaging in sort of, for example, RPM packages or Debian packages. So there are tools that enforce you to use standards. Often they are environment specific. So again, you have to deal with this stuff. The whole dependency management is up to the tool, or it depends on some server installations or stuff like this. And in this example, just because I want to use a specific tool like this live-rebel tool, it directly affects the delivery. So I have to modify or add an additional descriptor to it. Not a big deal in this example, but yeah, you have to keep that in mind. I think that you directly have to change something on your delivery just to support these tools. Other examples, application servers, it mentioned OSGI runtimes like Felix or those kinds of stuff, where you can configure pickup folders where you drop in stuff like bundles and things like this. That are the 5 patterns I just wanted to show. There's some sort of I haven't tackled yet the life cycle of those stuff. So normally when you I haven't tackled this. So for example, when you start by implementing some kind of Java library-based stuff, as I showed with MongoDB. It depends on how much you use it, right? If it's enough for you to have it in one explicit build or something like this, it might be enough to model it as I did. If you want to ship it all over your company, or maybe as a third-party stuff somewhere open source or over multiple places, you might want to implement them as your own Gradle plugins to ease reusing stuff and things like this. I thought I have a bit more time, but 5 minutes left. If you have any questions you want to, or things you want to discuss about this, maybe you have some tools you already have to implement. Ladies first.
About make build tool, is there any option to use Gradle?
We have no built-in support in, let's say, we have no built-in make task, let's say. I did some kind of, as I did for the command line stuff, I did some leveraging on this level. What I would suggest when you have to deal with make is maybe we try, or we want to add more native support for make or for all sorts of native things like C, C++, .NET. But I think they won't be make based. So if you want to leverage what you have, I would go with using the mechanism as I described, having some sort of exact task, maybe add a small wrapper around it. It depends on your environment. If you just want to run 3 tasks or so, it's quite easy. If you want to do it, if you want to have more flexibility, it depends on your make. What I saw in the past was I was at a customer where they had the make file which generates make files and then something like this, but if it's quite easy, it's just a couple of lines of code, I think.
Do you have a demo code in this thumb drive?
I can share it, I don't know, via Twitter or so. I haven't uploaded it anywhere yet.
Elias can upload, so I think it would be very helpful.
Um,
Some of the demo code.
I can upload it somewhere and I can share the link, I don't know, on Twitter or stuff like this, or or you drop me a line, or just give me your USB stick or whatever you want, or give me your email address and I can send you a link. Cool. Okay, you had a question too? The same. Okay. So then, thanks.